Welcome Calculus 2 students to an introductory lecture on parametric equations. I am choosing to use screen capture today to introduce you to this topic with the Desmos online graphing calculator. In MyOpenMath on the Block 4, Section 7.1 Parametric Equations, you're going to find some links to the Desmos graphs that I'm using here, and perhaps by the time you view this video there'll be several more. I will also have, of course, links to this lecture at the same place, but obviously I can't display that while I'm creating it. So let's go ahead and dive right in. So the first examples here are going to be circles, and we have experience from trigonometry and other classes understanding that the unit circle can be described using cosine and sine of an angle. And so as your angle, let's say t in this case, is moving from 0 to 2 pi, your cosine and your sine values will determine the x and y coordinates of the points on that circle. And so here we have a circle of radius 5, and so the only change is, of course, you have 5 times cosine t and 5 times sine t. And as it is, it looks like we just have the circle, and it's not all that interesting. But one of the things that sets parametric equations apart from the normal Cartesian equations that we are used to dealing with is that the t value is your input and you have two outputs, your x and y. And so if we really want to describe what's going on here, we have one dimension of input but now two dimensions of output. So with, if we just have x and y, then we have plug in x, get out y. And so our two-dimensional system is going to demonstrate what's going on. But there's a little bit more going on here, and if you really wanted to represent it, you would need a 3D graph. Our interest is not in doing 3D graphs. However, one of the things we can, one of the perspectives we can develop is if we think of t as time and consider how the curve is drawn. So in order to enable that, I have created this slider down here that's labeled t max, and this is the maximum value of t. This is telling us when to stop drawing the curve. And so as I move this slider, you're going to see the circle drawn, starting in the right side of the screen. And it will trace the circle. And here we have it complete, although there's a little bit more going on as we explore more t values. That shouldn't surprise you. You guys know that as you proceed to larger and larger angles, you're going to lap the unit circle, or the radius 5 circle as the case is here. So to demonstrate this, I'm going to display these initial and terminal points and back this up and trace through it again. In the beginning, the terminal point, the end point, is exactly the same as our initial point. And as I trace the circle, you can see that terminal point at the leading part of the curve. And here when I get to 2 pi, I'm going to be at the initial point again. But as I proceed all the way to 4 pi, I finish a second lap around the same circle. And so the parametric curve actually is not just the circle, but it turns out to be 2 laps around the circle. And I think that the seeing it in motion is a really helpful way to conceive of what's actually going on here as opposed to a static picture. I also want to emphasize how this is not the only way to parametrize this circle. This is pretty much the most common way, and I would say this is one that's good to commit to memory. But if I get rid of that parametrization for just a moment and have a look at a second parametrization, the same circle, it looks a little different. It looks like we are lapping it 4 times instead of 2. And in fact, if I bring back both simultaneously and start at the beginning, we can see that the red circle, which is defined by these equations with a 2t instead of a t, the red circle is being traced much faster than the blue circle. And so we're going to see that terminal point that's colored in red lap the terminal point in blue. And so even though the resulting static picture is the same circle, they're clearly being drawn in a couple different ways. We can actually get even more creative, so let's get rid of these parametrizations for the moment. And we can consider a third parameterization. And then this one, I've gone back to the just plain old sine t and cosine t, but I've switched them. So the x is defined by the sine function and the y is defined by the cosine function. as I proceed to draw the curve, not only do we see that we're starting at a different initial point than before, but we're actually tracing the circle in a different direction. We're going clockwise now, whereas before we were traveling counterclockwise. If I bring back the first one on the same screen here, we can see them on a collision course, and then again, and then again, and again, before they stop. And so there are lots of different ways to parametrize a circle based on where you start, stop, which direction you're headed, and how fast you're going. Of course, we have the simplest one, 5 cosine t, 5 sine t, but there are many others as well. If you want to play with this a bit more on your own, you also have the option of changing the radius, and that'll change the numbers in your equations as well, and so feel free to explore that. I've also designed another one using an ellipse, where here we have 5 cosine t and 5 sine t, as before, but I'm giving you the freedom to actually change some of those values. And so we can change the x and the y in different ways, and the effect that's going to have is going to be an ellipse instead of a circle. And so you should feel free to explore this as well with different values, but the point is you're going to have a very, very similar analogous parametrization of an ellipse as we do with a circle. And again, of course, we can parametrize these ellipses in many different ways. If I look at two of them simultaneously, once again you can see one of the parametrizations outpacing the other. And so you should be exploring both circles and ellipses in this context, and be able to recognize when a set of parametric equations is going to give you a circle or an ellipse. Now I encourage you to, as always, to read the textbook. In 7.1, in addition to teaching you some of the basics about parametrizing curves, they introduce cycloids. I'm not going to do an example of that. I encourage you to read the book to understand that, but you could imagine a bicycle wheel is rolling along the ground, and how does a particular point move in that scenario. But I thought it would be fun, though, to scroll down and look at these hypocycloids. And there's a set of equations right here that are going to describe those hypocycloids, and some pretty graphs down below. And so I've actually put one of those in Desmos as well. And what we're going to do here is actually hit play on this slider and watch it draw. And so this is a pretty cool little graph. If any of you have had a toy called a spirograph, then you could recognize some of the behavior that's going on here. And in a moment I'll show you how you can mess with the A and the B values that you're looking at over here on the left to make this picture look a little different and explore different hypocycloids. But I just thought this was kind of pretty and worth sharing. So let's just let that play out for a moment. A little past the halfway point now. And I've put the link to this Desmos graph on my Open Math as well, just because it's kind of nice. But you guys can explore the slider and the play options. I've chosen to play it just once and just in the one direction. And so here when it gets to 800 it'll actually stop. You can have these things go back and forth and cycle as you wish. Now when it stops, what I'm going to do is just leave that static picture up there. But now I'm going to change the A and the B values. And so if I choose B equal to something a little closer to A, we can see very, very different type of graph. If I choose A to be the smaller one, we can see how it gets a little bit inverted. When these have nice ratios, they'll be a bit simpler of a picture. Okay, basically the more decimal places that the ratio of A and B have, the more complicated and detailed and overlapping the picture is going to be. So anyway, I just think it's a bit of fun. Now, in the next lecture, we're going to explore parametrizations of lines. These are rather simple objects, and rather than use Desmos for that, I'll return to the whiteboard for a more traditional approach, mainly because it's going to be a nice environment for transitioning to some of the other skills we need to learn in 7.1. But for now, that's it for the Desmos demonstration for this first lecture, and I'll see you on the next lecture.